The following is a quick walkthrough on how to extract live economics data from FRED, which is a Federal Reserve Economic Database, and also do a forecasting on the extracted economics data. And in this video, we're going to extract CPI, the Consumer Price Index, from the Federal Reserve Economic Database using their FRED API keys. And once we have our hands on the CPI data, we're going to do some cleaning and get it ready for our time series forecasting using Facebook's very own univariate time series forecasting model called the Prophet. So once we feed in the data through Prophet and once we get the forecasted value or the predicted value, we are going to do some time series cross validation to check the accuracy or to evaluate the model. So let's get started. Alright, so as you could see, I've already imported the packages we need for this extraction of data from the Federal Reserve Economic Database. So these three are the basic packages which we use pretty much in all our projects. But I want you to notice this particular project package called FRED API, which will help us to create a live connection with FRED, the Federal Reserve Economic Database, and extract their data. And Plotly Express, the reason I use this is that it will help us to create easy interactive graphs. All right. So now the first step is to get our hands on with the data. So let's create our connection with FRED to do that. So let me just create something called FRED. In order to have access to the data, we need to have an API key from the FRED itself. Getting an API key from FRED is pretty easy. So this is how the FRED's homepage will look like. So once you go here and create an account, so this is how your page will look like, and sign up using Google and scroll down to API keys. If you're new here, you have to request API key and fill out the process, and you can get your API key sorted out. Once you are done with that, this is how your API key will be displayed. You can just copy this, paste it here. Now we are done with that. We have set up the connection. Now we can extract whatever data they have in the economic database. But in this video, we are going to analyze CPI. So what I'm going to do is that I'm going to come to FRED again, type CPI here, right? Once you type on CPI, so these are the data which turns up for our search term CPI. So as you could see, the second one looks good. It's monthly data and it's seasonally adjusted, and the data is from 1947 to December 22, and it has been recently updated as well. So what we'll do is that, let's just sort by popularity. Okay, so when you sort by popularity, that particular data set comes on top. So we'll take that and let's go to our Python environment here. So we have to bring this entire data into this Python environment. So how we can do that is that we can, the FRED package has a tool called search, which is almost, it's basically similar to the FRED web pages search bar. All right, just gonna create this, put this here, run it out. And now we have, so let me just put this into data and run data.head. All right, so now we have some metadata here. Since we put the exact title, the first one should be the one which we are looking for. All right, so let's see whether that's the one, monthly, seasonally adjusted. It has high popularity as well. So let's read the full title name to understand whether that's the one. Consumer Price Index for all urban customers. Yep, that's the one. So now we have the hands on the metadata. So now we have to extract all the data points within it. So there is an easy way to do that in FRED. What we can do is that we can use a function called get series. All right, what this get series is, each and every metadata will have a unique series ID. All right, so you can just copy that. So this particular metadata series ID is this. Now if you just name this as values for a sec, CPI, run it. Yep, now we have the data within our environment, starting from 1947 to 2022 December. All right, so 912 rows. So this is monthly data, so we have total 912 data points, and we have the float data type as well. Now let me create a dedicated data frame with index reset. Now if I run df, sweet, now we have a date column which has a column name index which has an x, and we can change it. and we have the values variable. All right, so this is basically a univariate data set we have here. So now you can either feed this entire data set into the the Facebook profit model, the forecasting model, or you can split it out. But what I thought was I'll just feed in data starting from 1990, let's say. All right, so I'm just gonna create a new data frame df that will have only index greater than value starting from 1960. All right, so now if you run this, oh, so I said 1990, right? So it should be 1989. Now if I run this, we have the exclusive data set where the data starts from 1990 January to which ends on the December of 2022, right? So let's just do a small interactive line plot of this. So this is where plotly comes in. So fig is equal to px.line to index values. The title should be equal to, you can give a title name, CPI average 1990 to 2022. There seems to be some issue somewhere. Here we go. Oh, it's PEX actually. It's plotly. All right. So now we have a a line graph here. So as you could see, this is an interactive line graph, a simple interactive line graph. So you can just hover over this and you can see each data points. So this is why I like Plotly. If you click here, it will take you to the Plotly's website. You can just check it out, it's interesting. And now let's set up our data frame to feed it into the profit model. All right, so there are certain conditions which you should keep in mind when you are working with profit for time series forecasting models. All right, so the profit time series forecasting model can only take in univariate data set. That's what we have here, which actually means it has only one variable. Next, let me just type this out. Conditions for efficient profit model, right? First is univariate data. The second should be the profit model by default is set up to efficiently analyze only daily data sets. All right, by the data which we have is a monthly data set, right? Monthly data values based on monthly. So but by default Plotly is set up to forecast daily data sets. You should keep that in mind. So but if you are using weekly or monthly data set, we should change some parameters based on that. Profit is predetermined to forecast daily data. All right, so the third thing and the most important thing is that profit can only read two column names. All right, by two column names I mean, so here we have, when it comes to most univariate data sets, we'll have only two columns. Mostly it will be a date column and a variable column, and we have two column names here which says index and values. All right, but profit has a dedicated column names, which if the data frame has that column names only, it can read it. All right, so those column names are, so the date column should be DS and the variable should be Y. All right, for example, if I feed this right now without changing the column names, it will turn up an error for me. I'll show that to you when I run the model. So these are something you should keep in mind. And the other thing is the date should be in datetime. All right, so now let's bring in the profit model in our environment. Import profit. Training the model is pretty simple. It's gonna just take 3 lines. That's the best part about this particular Facebook profit model. So now let me just fit in the data frame which I haven't changed the column names. All right, just to show you what the errors will be. As you could see, the errors data frame must have columns ds and y with the dates and values respectively. All right, so without changing the dates, the column names, you can't forecast it. So what we can do is that I'm just going to change the column name to df2 is equal to df2. Index changes to ds and values change to y. Now if you run this, now we have the column just like how the model wants. Now if you run this, there will be, and it runs perfectly fine. All right, so now we have fitted our model in the in our forecasting model itself. So now we have to create future data frames. By future data frames, we are gonna let the forecasting model know how far in the future we need the data for. All right, for example, we have the actual data set ends on December 1st of 2022. All right, what is the number of future data points we need the forecast for is what we're gonna find out now. All right, or we're gonna set up now. Let's name something called future ml make future data frames. Now within this is where you enter the number of future data points which we need. All right, so just keep in mind, like I said, by default it has been, the profit model is set to understand daily data. All right, so if you just end of periods, let's say you need 10 data points in the future. All right, run this. Now if you run future dot tail, it's going to give you 10 data points in the future. All right, by 10 data points by default, in profit by default, what it means is that 10 days in the future. All right, but we have monthly data here. If you see, the last date we have is December 1st. Since we didn't mention our frequency parameter, or whether it's monthly or weekly, it's just giving us 10 days after December 1st. That's why that model ends on 11th December of 2022. Right, so in order to solve this, we have to create something called frequency ms. All right, ms basically means monthly. If it's weekly, you should just give w. That's it. All right, so now if you run this and run, now it's going to create 10 data points in the future with keeping in mind it's monthly. All right, that means it's going to create forecast for 10 months. So the 10 months from December 1st of 2022 will be October 1st of 2023. That's what we have here. Right, so that's what you want. Now let's ask the model to predict the values. All right, so let me just do something called reset ml.predict. What is that? Could be future. All right, so now we have the forecasted values itself. All right, so the data frame has a lot of values, but there are only 3 values which you should keep in mind. All right, one is y hat lower, one is y hat upper, and the y hat itself. All right, here you can ask me what is a predicted value. The actual forecast value on a particular date is y hat. All right, which basically means on October 1st of 2023, the model predicts the CPI average to be around 291. That's what it predicts. All right, so this is the predicted value, and y hat lower and y hat upper is the ranges. All right, so what it basically means is that the model predicts an y hat of 291. All right, but all right, the values should be 291. If it is not 291, it could be anywhere between this y hat lower 287 and y hat upper 295. That's what it means. All right, so let's just filter out this column to get what we basically need. We need the dates, then we need something called y hat, then we need the y hat lower, then we just need the y hat upper. Let's just check that. Yeah, now this data looks much clean. We have the actual predicted value, their lower range and their upper range, right? So other interesting thing about the profit model is that this model has its own plotting tools. All right, so let's use that to plot a graph which will clearly show us how this looks like. Plot the result. All right, so as you could see, the black dotted lines are the actual values from the data set. All right, and the blue solid line, it's a predicted value, it's the forecast, it's basically y hat. And the shaded blue, all right, it's that range which I told you. All right, the lower line is y hat lower, the upper line is y hat upper. All right, so what it basically means is that on this particular time period and future, the particular value will lie within that. That's what it means, like I explained here. All right, the value should be 291. If it is not 291, it will be anywhere between these two. That's what it means. All right, so there is this one other interesting plotting component in profit model itself. So let me just show you that. 2 is equal to plot components. All right, so this basically shows us the trend from the historical perspective and trend based on each month. All right, so how it has been all throughout each months, all throughout this entire data set period. As you could see, it has been on a highs during after March, and it has usually the monthly hikes. All right, it reaches hike during October, let's say September, anytime between September to November. It should be October to November, let's say. So that's how it is. This is an interesting graph. So based on the frequency which you are providing, since we are having monthly data, it is showing us in month wise. If it is weekly data, it will show us from week wise and all those stuff. All right, so that's how it is. Now we have predicted 10 months into the future. You should also keep in mind these models, the far away you predict, the prediction accuracy will go down as well. All right, so that is why you should keep the predictions as closer as possible so that the prediction values will be tight and the prediction accuracy will be higher. For example, since I'm just predicting 10 months into the future, it has a tight y hat upper and y hat lower, and within which the accuracy, it says the range will be within that. For example, if I predict for, where is it, 120 months into the future, all right, which will be basically be December 1st of 2032, or we are predicting until that, then our values, then the graph will look something like this. As you could see, as it moves further towards further in the future, the y hat and y hat lower and upper ranges expand. All right, just to say that the accuracy fades out when it moves further in the future. So that's why it's always good to keep it close. All right, so let's stick to this. Now we have predicted these values. So when it comes to time series forecasting, there is something you should consider as well. There is something called cross validation. All right, so we have to evaluate the model whether the model is good, or if the model is not accurate, we can actually fine tune it. That's what it is. But interestingly for us, Profit has his own cross validation tools within the profit model itself. All right, so we can use that to create models. So what we can do here is, so let me just import from profit dot diagnostic import cross validation performance metrics. Now let me underscore CV results. What I'm gonna do is that I'm gonna split this entire data we have, and we are gonna run multiple training on that, and this is gonna take some time, honestly. So let's do cross validation model is equal to the model which we have. Then we have to give an initial data for the validation to consider. So like I said, by default the model is set for daily data, right? So we want to change it to monthly data by using PD2 time data, 30 days in a month into how many months? Let's say 20 months. and unit should be D. Now let's set up a period. So after each iteration of the cycle, it will add whatever the months you given within this period to this training set, and it will run again and again until there is no enough data. So let me just do 5. Now let me oops. Alright, so that should be it. Alright, so basically, just a second. Let's import the performance metrics as well so that we can run that simultaneously. Alright, so basically what we are asking the model to do is that we are asking the model to take an initial data of since it is by default and daily, we're asking it to take 30 days into 20 months, alright, and run the model in it and forecast it for this particular period. Once it does that, it is going to add another period of this 30 days into 5 months into it, run the same, forecast it to this particular period, horizon period. That is what horizon means, alright. So this is going to keep doing this cycle until there is no enough data, alright. So that is going to take some time. I think it's going to run through 74 iterations. So once that is done, we can see the root mean square, the mean square error, the MAE values to understand how the model is performing, right? Alright, so as you can see now, it has completed its entire iteration. So now we can import another profit package called the profit.plot profit cross validation metric. Now we can plot this. For example, figure is equal to plot cross validation metric. We're gonna bring in the CV results. The metric is gonna be, let's just do RMSE for now. Alright, so this is how it looks like. We can also open this in a data frame. So if you run DFP, this is how it looks like. Alright, so basically RMSE should be closer to 0. The more that closest to 0, the more accurate the model is. Alright, same with MAE as well, and that's how it is. So you can obviously, there are a lot of rooms to improve. The RMSE is 2.4. You can obviously keep improving to improve the overall forecast accuracy. So now it shows RMSE. We can obviously change it to MAE if you want to see the MAE values. Alright, so this cross validation will give you an idea how the whole model is performing, and based on that you can actually fine tune it, or you can change the model, or whatever you can do with that. So this is how you extract data from Fred, and you can store, this is how we store it in a data frame, and this is how you bring in profit model into your Python environment, and this is how you do a simple forecast to understand how your values will look in the future. All right, so that's it.